Hello everyone, I'm Jordan Gilbert. This is my Lab 10 demo where we're combining the IMU data, GPS data, and the live video stream all in one app. So let's see here. Taking a look at a quick diagram. So a lot going on here. So top left, I'm using a feather, an Adafruit Feather NRF 52840 board, same as my last lab. I'm using MPU 6500 in place of the BNO 055 because mine didn't work. For this lab, I changed to using SPI for that device. It supports SPI and I2C, and since I'm doing I2C between the Featherboard and the Raspberry Pi, I opted to switch that to SPI. So pretty similar to the last lab, reading the data from the MPU at 20 hertz with an IMU thread, and then publishing that over a Z bus through a IMU data chan, which is basically just an internal channel for inter-process communication. And then for the actual I2C stuff for the Nordic board, so there's a driver called Twist, which I believe is 2-wire interface slave. So I'm basically registering my device as a slave device, and I chose just 42, so arbitrary number 42 for the address. And then I'm using a 20-byte register file for the data. So there's a 4-byte fixed number that the Raspberry Pi can use to pull and basically make sure that it's getting the correct data. It's just a fixed 4 bytes. And then I've got the sequence number, and then the 3 values of interest: the heading, roll and pitch, or yaw roll and pitch, however you want to say it. And then I've still have my status thread, which basically just blinks an LED at 2 hertz. For the Raspberry Pi, there's a couple of things going on here. So the GPS D and MJPEG streamer are both system D services that are running, and then the rest of this is kind of all its own Python script that I wrote that also is running as a system D service. So in the Python script, there's an I2C thread that pulls using SMBus2 address 42 from the NRF and gets the data. And then the GPS thread at 1 hertz gets the data from GPSD. Both of those just get thrown into a shared state, and then the main loop at 10 hertz is packing that into UDP packets and sending it out over, or sending it to UDP port 5005. I have it configured in the systemd service file to send to my host machine IP address. That's pretty much it for the Raspberry Pi portion. The rest is a host Python script, which is like a super simple web application. It's got a UDP listener, which takes in those UDP packets and breaks them down, just takes the latest snapshot. And then there's a Flask app that runs at port 5080 with an endpoint, HTTP endpoint at stream, which throws out the data. And then I've got some JavaScript that takes the data and has some fancy gauges for the yaw, roll, and pitch, leaflet map, and open street map for GPS data. And then I'm just directly pulling in, embedding the stream. I can't remember the exact route, but there's a route you can use to just grab the stream from MJPEG streamer. So let's actually take a look at some of that stuff right now. So here's the setup. So these orange wires here is the SPI connection. These wires here is the I2C that goes underneath to the Pi on the bottom. And then this is the MPU 6500 and the Featherboard right here. So the Wireshark there, that's the UDP packets coming in. The 6862 is my Pi, and then the 6870 is my host PC. And then let me move these out of the way. So this is the host what is it, the host Python script running. So I've got the 3 little gauges, those update. When moving that around, I've got the camera right here, and then in the top right there you can see the GPS location. I got that blurred out so I don't have my location, but that is an actual map of the of the GPS fix. All right, thanks for watching.